This tutorial video is going to help prepare you for the test in Similarity, Congruence, and Proofs Part 3 unit. Now, several of these questions revolve around having a right triangle with an altitude. That's what this is right here. Alright, when you have a perpendicular line going out to the hypotenuse like this, making two smaller right triangles on the left and the right. That's a special situation, and it creates a few formulas that you're going to want to write down. So here comes some notes. If I were you, I would take out a sheet of paper and I would draw this picture and copy down these three formulas. Alright, because these equations are going to help you do several problems on this test. I've used the letter A here because this is the altitude of the triangle, and this is actually a right. The big triangle is a right triangle as well. So I use A for altitude. Now, looking at the big triangle, you have leg 1, leg 2, and then of course the hypotenuse. So that's why I did L1, L2, and H. Now, looking at the hypotenuse of the big triangle, which I called H, these two parts of the hypotenuse we could call part 1 and part 2. Notice how I have part 1 and leg 1 on the same side, and I have part 2 and leg 2 on the same side. Alright, that's important when you're doing these formulas. Okay, now what do these formulas mean? I hope you wrote them down because I'm going to wind up sort of erasing them. So let's focus on this top formula first, the one that involves the altitude and the two parts. So hopefully you see that this is saying that the altitude squared is equal to part times part. So let's jump down to a different picture for a moment. So say if I knew that this was x and I knew that this was 3 and this was 7. That formula would say that x squared is equal to 3 times 7. So x squared would equal 21, and x would wind up being the square root of 21. Alright, that's what that formula is saying. Okay, let's look at the next formula. The one involving the leg and a part and the hypotenuse. And it's saying the leg squared is equal to part times hypotenuse. Leg 1 squared is equal to part 1 times hypotenuse. Okay, so again, jumping down here, say if I call this x, and what did I say? This was 3 and this was 7. Let's go with that again. Say if I had this. So the little formula said that the leg squared, alright, so that would be x squared, should equal the part, part 1, alright, the part that's with the leg, times the hypotenuse. Well, the hypotenuse is both of these put together, so the hypotenuse is 10. Alright, so the leg squared should equal part times 10. Alright, part times the hypotenuse. Okay, what if, I'll call it y since I'm throwing it over here. What would be the situation now? Alright, because this is the other formula that's really the same thing, just on the other side. It's another formula about this, this time I'm talking about the other leg. I'm talking about y. So again, it should be leg squared is equal to part times the hypotenuse. But it's got to be the part that's over here on the same side as the leg. So I'm going to say 7. And then the hypotenuse is 10. Alright, and then you could go from there. Okay, so those are the basic formulas that we're going to use many times on this. So when you see a right triangle and then an altitude, think about those three formulas. So, on this problem, we're dealing with the altitude x, and then we've got the two parts. So that reminds me of the very first formula where we have the altitude squared is equal to part times part. Okay, so that means that, so using that formula, the altitude squared should equal part times part. So that should equal 9 times 16. Okay, so alright, so that's 144. And then, so if I want x by itself, of course I'm going to take the square root of both sides. So that's going to be 12. So x should equal 12. Okay, so that's why the answer was 12. Now, moving on to the next one. This time they did not give us the hypotenuse. Sorry, they didn't give us the altitude. So we're not going to use that same formula. We want the length of SR over here. Ultimately, we want this. But we don't have enough information on that side of the triangle. We don't know what this is. We don't know what the altitude is. So we're not ready to deal with that yet. So I don't know. I'm afraid I'm about to be doing this the long way, but I can't see a quicker way. So I'm just going to dive in. What we do have is we have the leg and we have this part. So that reminds me of the formula that says, you know, the leg squared is equal to part times hypotenuse. Okay, I mean, I said like leg 1, leg 2, part 1, but you know, it's the leg and the part that's nearby. So leg squared is equal to part times hypotenuse. It's I've got the leg and the part. Now, as far as the hypotenuse would be this entire thing. I don't know what that is, but I could figure it out. So, you know, that's the one unknown here. So let's go ahead and use this formula to find the hypotenuse. So let's see, leg squared. So I've got 20 squared is equal to this part times the hypotenuse. Alright, so that's going to be 400 is equal to 16h. If I divide both sides by 16, that should tell me what the hypotenuse is. Alright, so 400 divided by 16 is 25. Okay, so great. Now we know that the hypotenuse is 25. So that's very helpful. So now what we really want is the length of SR. So I don't think I am going to need my little special formulas that we learned over here. I don't think I'm going to need these anymore. I think it's time for good old Pythagorean Theorem. A squared plus b squared equals c squared. Remember that? Okay, so ignore the altitude and just focus on the fact that we have a leg, and a hypotenuse. So leg squared plus leg squared should equal the hypotenuse squared. You know, a squared plus b squared equals c squared, the Pythagorean theorem. We should be able to find SR this way. So this will be x squared plus 400 is equal to 625. So, you know, if we subtract 400 from both sides, leave myself a little bit more space, that's going to leave us with 225. And then if we take the square root of both sides, that's going to be 15. So that should be the length of SR, which should be 15. Okay, so that was a pretty involved problem. It took 2 stages. So, you know, that might take a little bit of practice. You might want to go back and redo that one by yourself to make sure you really have it down. Okay. So this problem is not like the ones that we just did. So let's switch our brain. What value of x would make TV parallel to QS? Well, if these lines are parallel, if TV is parallel to QS, then these lengths should be proportional. Meaning, if I make fractions out of them, they should be equal. So, for example, x plus 4 over x minus 3, top over bottom, should equal x plus 10 over x. I should be able to make an equation like this. This only works if these are parallel. So let's just solve this equation, and then that should give us the necessary value of x. So I'm going to do what you call cross multiplying, where you multiply these and put them on one side. So let's see if I can squeeze it in over here. So I've got x times x plus 4, and then I'm going to do this diagonal. So I've got x minus 3 times x plus 10. So I've got to solve this out. So a little distributive property here. So I will have x squared plus 4x. And over here, I've got to FOIL this, or it's really you're doing the distributive property twice. So x times x is x squared. X times 10 is 10x. Now I'm distributing this negative 3. So negative 3 times x is negative 3x. And negative 3 times 10 is negative 30. Okay, so now I'm going to combine my like terms. So I'm just bringing that down. But so on the right hand side, I've got x squared. 10x minus 3x is 7x. And then there's my minus 30. Now, I want to get this stuff sort of all together on one side if I can. So the first thing I might do is subtract x squared from both sides. But look what happens. Both of these x squares cancel each other out. They're both gone. So that's going to leave me with just the 4x is equal to 7x minus 30. Okay, so I still want to get these x's together, so I will subtract 7x from both sides. So that's going to leave me with negative 3x is equal to negative 30. Now it's time to divide by the negative 3. And that's going to leave me with x is equal to 10. And that's it. So the answer should be 10. And there you go. All right, let's look at the next one. In the diagram, we have all these numbers that are shown. To prove that these triangles are similar by side angle side similarity theorem, it can be stated that df over gf, okay, let's get those going. All right, so we have df is like this one. Okay, and then gf is right here. And then we have EH over, we have EF over HF. So we have EF, which is like this, and then HF, which is like this. So if we're going for side angle side, we need a pair of sides, a pair of angles, and another pair of sides. So we have the two S's, all right? We have the blue side and the little pink side. Check. And down here we have another pair of sides. We have the big blue side and the little pink side. Check. So now we need a pair of angles. But specifically, it has to be the angle that's in the middle between the two sides. So it has to be this angle right here that I just colored in green. It has to be angle F. Okay, which also could be known as angle GFH. Whoa, could be called GFH, or it could be called angle D, if I want to look way out here, DFE. Okay, the key is look for the F to be in the middle, because that's what makes it angle F. Okay, so to prove it can be stated that this is true, and we need these two angle F's to be congruent to each other. So DFE, see how we have F in the middle, so that looks good. And then GFH. Okay, that's just like what we were talking about. So this is going to be the answer. See how this one, we have the F in the middle here. EFD, that one's fine. But then this one is angle H. That's irrelevant. So it's this, this is the one that's got to be the answer. Okay, because we need angle F congruent to angle F, because it's the shared angle for both triangles, and it's the one in the middle. Okay, so let's check it out and see. And sure enough, there you go. Okay, consider the two triangles that are shown here, the big one and then the smaller one on the inside. If the triangles are similar, which must be true? Well, if the triangles are similar, then the corresponding sides must be proportional. So let's just match these up. All right, well, in the small triangle, all right, we have RY. Okay, you know what, maybe I'll use this line to separate it all out. So in the bigger triangle, that would correspond to RS. So RY over RS. Okay, now in the smaller triangle, next we have RX. And in the big triangle, that would correspond with RT. And then finally, in the small triangle, we have XY. And in the big triangle, that would correspond with ST. Okay, so I'm looking for these three things among over here. So I see, okay, I have RY over YS. That's not what I was looking for. So I'm going to keep looking. I have RY over RS, check. RX over RT, check. XY over TS. Well, TS and ST are the same thing. So check. So this one should be the answer. I don't know if this is one of those ones with multiple answers, so I'm going to keep looking. So I have RY over RS, RX over RT, RS. Yeah, I think this is just multiple choice. So let's see if I was right. Yep, that's it. All right, let's take a look at this one. We have triangle TVW is dilated according to this rule, which takes every x and y and multiplies it by 3/4 to get a new x and y coordinate, which would be T prime, V prime, W prime, which is not shown. What are the coordinates of the endpoints of segment T prime V prime? Well, it looks like we just need to know what are the original coordinates of T and V. And then we'll just do this little formula to it. So looking at T over here, I see it is -4, okay, comma 8. That's the original T. Now looking at the original V, it seems to be right here on the y-axis. So that is the point 0, comma 4. So if we do the formula, if I want T prime, then the way I get T prime is I'm going to do 3/4 times the x value and 3/4 times the y value. Okay, so in other words, what is 3/4 times -4? Well, I know that that is going to be -3. All right, and the reason why I know that is because 4, look at this part, 4 divided by -4, that's -1. And so now I have 3 times -1, which is -3. So I get -3. Okay, now I'm going to do the same thing with the 8. What is 3/4 times 8? Okay, so I did 3/4 times -4. And now I'm going to do 3/4 times 8. Well, 4 goes into 8 twice. So this becomes 3 times 2. So that's going to be 6. All right. 4 goes into 8 twice. So that leaves 3 times 2, which is 6. So that's going to be my T prime. All right. Now I'm going to do the same thing with 0 and 4. All right. I'm just going to multiply them by 3/4. Let me make space. So if I do 3/4 times 0, all right, 0 times anything is just going to be 0. So V prime going to have 0. Okay, now what if I do 3/4 times 4? Well, the 4's cancel each other out. So that's just going to be 3. So these should be the coordinates of my endpoints. Okay, so -3, 6. All right, so that eliminates these bottom two choices. And then 0, comma 3. So the top answer should be the answer. And there you go. Now, if you had any trouble following my math, for example, when I did 3/4 times -4 and stuff, and I was kind of doing it in my head mostly, you should be able to do that. But, you know, if it's a struggle, if you have a solid calculator like a TI-30XS Multiview, then your calculator should be able to do this type of thing. So I could do 3/4 using my fraction button and -4. So if you have a good calculator, it should be able to do it for you. I'm just saying. Get a good calculator. Alright, moving on. If an image of a triangle is congruent to the pre-image, then the scale factor must be 1. Alright, I mean, if the images are congruent, then that means the size didn't change. You know, you had the pre-image and then the image, you know, it didn't get any bigger or smaller. So that means everything had to be multiplied by 1. So there are no changes. So the scale factor of dilation would have to be 1. So yeah, that's just kind of common sense. Alright, moving on. In triangle A prime, B prime, C prime, is triangle A prime, B prime, C prime a dilation of ABC? Explain. Okay, if you look at the distance from the center of dilation, P, out to A, okay? So the pre-image A. So that original distance is 2. Now, if you look at the distance to the image, A prime, then now that total distance, don't look at just the 4, it's really 6. So we went from a distance of 2 to a distance of 6. All right, how did we do that? If we did 2 times 3, then you would arrive at your 6. So this 3 would be the scale factor. All right, that's how many times bigger the distance got. So if this is going to be a dilation, that should be the same for all of these. So let's look at point B. So the original distance of point B is 3. Okay. Now, if we do that same scale factor of 3, then the new distance should be 9. But look what the new distance is. The new distance here is 8. So this is not a scale factor of 3. All right, it's not, the new distance is not triple the original distance like it was over here. So that means this is not a dilation because it does not have a scale factor that's the same. It doesn't have the same scale factor. So we can throw out both of these yes answers immediately. So no, it is not a dilation because the points of the image are not moved away from the center of dilation proportionally. Yeah, that's it. Okay, it's not proportional. It's not the same scale factor. So no, it's not a dilation because the sides of the image are proportionally reduced. If they were proportionally reduced, it would be a dilation. Even if something is reduced, it can still be a dilation if it's proportional. So that doesn't even make sense. So this third choice has to be the answer. And there you go. All right. To solve this next problem, we need to pay attention to these markings. See the single mark and another single mark. That means that if this is 4 feet, then this is also 4. And so these are also the same over here. So if that's 3, then this is 3 as well. All right, great. One of the things that means is that the large side over here is 8, and the large side over here is 6. Now, when you have midpoints that are being connected like this, then these two triangles are similar. The triangle on top and then the big triangle, those are similar triangles. So we are supposed to find the length of AC. We're supposed to find this guy down here. So we should be able to set up a proportion because since these are similar triangles, the side lengths should be proportional. So I'm going to make my ratios as big over small. All right, I'm going to go big over small. So this AC is part of the big triangle. So if I go x over 9, all right, those are corresponding sides, big over small. Okay, now I can pick any other pair of corresponding sides, but I'm going to be sure to go big over small. So for example, say if I pick this 8, all right, that's the big side of the big triangle. So I'll put that in the top because I'm doing big over small. Now the corresponding side on the small triangle should be this, just the MB, and that's 4. So 8 over 4. Okay, so it's just a matter of solving this. So actually, you can probably see that these are double, right? Of course. So if this is 4 and this is 8, that's a double size. This is 3 and this is 6, double size. If this is 9, this should be 18, double size. So I don't really have to solve this equation. Now that I look at it more carefully, it's obviously going to be 18. But, you know, it's the same thing I would have gotten. If I did solve this little equation that I just set up, 8 over 4 is just 2. And then if you multiply it by 9 on both sides, skirt, then you have x is equal to 18, either way. Okay, double double. Now, I think this is the last, nope, not the last question. Got carried away. Not the last question, but let's just take a look and see what we got. A partial proof was constructed given that MNOP is a parallelogram. Which statements should fill in the blanks in the last line of the proof? Okay, so let's just scan through this. By the definition of a parallelogram, these are parallel and these are parallel. Great. Using MP as a transversal, meaning a line that's cutting across these parallel lines, M and P are same side interior angles, so they are supplementary. All right, so this and this are supplementary, meaning they should add up to 180. Okay, great, that's what they're saying so far. Using NO as a transversal, okay, angle N and angle O are same side interior angles. Yeah, that makes sense. So they are supplementary. All right, so like this and this have got to add up to 180. Now, using OP as a transversal, okay, now we're looking at these lines up here as being the ones that are parallel. So we're looking at these as the parallel lines being cut by the transversal like this now. So looking at OP as a transversal, O and P are same side interior. So they should be supplementary to each other. Okay, so these should be supplementary to each other. So if the blue ones should be supplementary to each other, the pink ones should be supplementary to each other, and now these yellow ones should also be supplementary to each other. What does that leave? Therefore, blank and blank should also be true because they are supplements of the same angle. All right, the key is this last statement here. They are supplements of the same angle. So we need to look for two things that are supplements of the same angle. So look at angle O, for example. Angle N is a supplement, all right, because these are supplementary, okay, and angle P is a supplement, all right, because these are supplementary to each other. So angle P and angle N are both supplementary to the same angle. So it makes sense that angle P should be congruent to angle N because they are supplements of the same angle. In the same way, I could pick angle M and do the same analysis. Okay, if I look at angle M, well, you know, maybe I should pick a different angle this time, because that's going to give me the same thing. Say if I picked angle P instead. All right, look at angle P. Angle O is a supplement, and angle M is also a supplement. All right, so both of these, angle M and angle O, are both supplementary to the same angle, supplements of the same angle. So we should be able to say that angle M is congruent to angle O, because they are both supplementary to the same angle. So I think these are the two statements that would fit here, all right? And we know that because of the whole supplements of the same angle business. So let's see. So we're not talking about these up here. It's these down here. So we want P congruent to N, okay, which I see right here, and we want M congruent to O, which is right here. So I think it's going to be the bottom one will be the answer. Boom! Awesome sauce. All right, we have two more questions left. Is rectangle EFGH the result of a dilation of rectangle ABCD with a center of dilation at the origin, why or why not? All right, well, let's analyze carefully. Look at the distance from the origin to point C. All right, that distance is 3. Now, that's the pre-image. Now, the image is landing over here at distance 4. So it went from being 3 away to being 4 away. So the question is, what scale factor would cause that? You know, 3 times what would give you 4? Well, if you want to know the answer to that, just divide by 3 on both sides. Okay, so the scale factor would be 4 over 3. So, so keep in mind that if this is a dilation, the scale factor is 4 over 3. So now just look all around and see if that happened in all dimensions. So going to the right, it went from 3 to 4. Going to the left, it went from 3 to 4. Going up, it went from 3 to 4. So it seems like everything is moving at a scale factor of 4 over 3. So this is going to be a dilation. All right, so it's going to be one of these yeses. Yes, because the corresponding sides are parallel and have lengths in a ratio of 4 to 3. All right, and that's that scale factor we were just talking about. So that should be the answer right there. Boom! There you go. All right, last problem. This one sort of looks like those problems where we used our fancy similarity theorems involving an altitude of a right triangle. It looks like that, but I don't think we actually need those special formulas, because we're trying to find y, which is one side of a right triangle, and we're given both of the other sides of the right triangle. All right, we're given this leg of the right triangle, and we're given the hypotenuse of the right triangle. Okay, so basically, I mean, look at it this way. We've got this right triangle. We're supposed to find y. We know that this is 6, and we know that the hypotenuse is 12 if you add up the 9 and the 3. So you've been knowing how to find the missing side of a right triangle for a long time now. You just do the Pythagorean Theorem. A squared plus b squared equals c squared. All right, so y squared plus 6 squared should equal 12 squared, the Pythagorean Theorem. So y squared plus 36 is equal to 144. Subtract 36 from both sides. So you get y squared is equal to, I think this is 108. Okay, and then of course we need to take the square root of both sides. So it's just a matter of what's the square root of 108. And that's 6 radical 3. So this should be the answer right here. And there you go. I hope this video has been helpful, and I hope you took good notes because they will help you when you take the test. Good luck.